Well, good afternoon, everybody. This has been, as I agree with what Phil said, very fascinating, interesting. I've been able to listen in most of the day, and I'm glad to also come in right behind him because the work I'm doing that also is funded by NSF Phase One SBIR. Um, is one that is producing or generating gravity waves in the lab. And in this case, utilizing plasma uh, formed by a high energy spark that will produce energy densities on the order of 10 to the 12th and joules per meter cubed, which is scratching on the levels that the literature has shown is at the level to distort space-time. And so able to erect a an experiment to show this. So let me go, if you go to the next slide, you will see that this is the actual experiment. This is an interferometer, and it's a desktop size one capable of showing variations on the order of the wavelengths of the lasers that we're using. Use both the 532 nanometer laser and the 650 nanometer laser. The reason why that I wanted to utilize both of those wavelengths was to mitigate some of the issues that could be responsible for causing the fringes to move around, such as index of refraction changes. We also kind of ruled out vibrations and shock waves by the way we did the experiment. So the index of refraction, by showing one that the variation that you got from these two different wavelengths it was invariant to wavelength. The magnitude of the movements of the fringes were invariant to the wavelengths, and that would not be the case with index of refraction. And also, we varied the way that we oriented the test device with the laser. I see the question that just popped up. So that little device right in the center at the bottom,
Well, let's
that's
just
the
read the
spark gap.
question. I know that that might throw you off a little bit on timing chance, but we've got a question. Where does
Yeah,
the spark gap happen on the slide with the
yeah,
Michelson
yeah. I was just trying to
interferometer?
answer that as we spoke. The little device, I don't know if you can, well, you can't see mine, but if you uh right in the center where you see mirror at the bottom, that little two-pronged looking device is the spark gap right there. And the laser cuts right through it. And so any variations in the optical path length will show up as movements of the fringes on the screen, which we image with the camera. We did the processing, as you can see on the bottom right, and that movement is associated directly to a fraction of the wavelength, and that could be associated to nanometers. So if you go back, if you go to, not back, but go to the next slide, you'll see the actual measures. We saw movements peak at about 140 to 150 nanometers of movement in the optical path length, um, compared to a pad length of about 850 to 900 nanometers. So you can calculate the stress. So just quickly, as you can see, the variation on the energy density, what happened to the movement, um, as well as we had different orientations, as you can see, that didn't really affect the fringe movement. And then you can go to the last slide now, and I'll finish up with a couple of things. We're adding a rotational factor to the experiment now, and so that we will have this spark moving very rapidly in a circular form. this will add an additional dynamic. Phil had mentioned the quadrupole moment. This change in that quadrupole moment will add to the stress, and we know that we can have a sequence of sparks. So this will be running around that track that you can see. I call a gwavelet carousel. Gwavelets is my short name for gravitational waves, but it'll be running around that carousel at a very high rate, and we should see an enhanced stress. And then finally, our expectation is to do this experiment, then move to an experiment that shows us that any thrust created by the formation of these gravitational waves in a particular direction. If so, then we can begin to characterize what it would take to make something that could create significant movement by this particular approach. So that's where I'll leave it. Just quickly, the paper I just wrote that I just sent for publication. I just got notice today, as a matter of fact, at noon, that it is being accepted for publication. So
Congratulations.
in a journal, the European Journal of Engineering and Research. So that's good news, and I'm excited about it.
That's
Great. And
awesome.
Chance, I know, as Larry's saying, I mean, I've heard so many of your colleagues so excited about your work and just the experiments that you're doing in the lab to really build, and then also the vision that you've had for Alcubierre drive
Yeah,
and also hyperloops type concepts. So, great to see you in the lab doing the work
thank
to
you. Thank you,
towards
man.
these things. Thank
Thank
you.
you for your support and for all this stuff too.